Hi, good morning. In class, we define subnet. We already defined net as a function S from a directed set D to a set capital X. And we have that this net is a generalization of a sequence. Sequence not a term on the subsequence. In the same way, we can define a subnet. See, suppose S from D to X be a net and T from E to X be another net where E and D are directed sets. So this is the case. This is D. This is capital X. S is from D to X. And this is E. T is from E to X. Then we say T is a subnet of S. If there exists a function, say N, from E to D, then T is a subnet of S. If there exists a function N from E to D such that T is equal to S composition N. And 2. For any N belongs to D, there exists a P belongs to E such that for all M follows P, M in the image NM should follows N. So this is the condition. T is said to be a subnet of S if there exists a function N from E to D such that T is equal to S composition N. And for any N belongs to D, there exists a P belongs to E such that for all M follows P in E, NM follows N in D. Now we connect the relation between the convergence and cluster point of nets and subnets. And this is the last theorem in our section. This is a theorem. Let S from D to X be a net in a topological space capital X. Then X is a cluster point of S. If and only if S has a subnet, say T, converging to X in capital X. S from D to X is a net in the topological space capital X. Then X is a cluster point of S if and only if S has a subnet T converging to X. So first we assume that S has a subnet T converging to X. So proof. Assume first that S has a subnet T converging to X in capital X. Adonde, by definition of subnet, therefore, T, a subnet T from E to X converging to X in capital X. Therefore, by definition of subnet, there exists a function N from E to D such that T is equal to S composition N. And the other condition, for every N belongs to D, there exists P belongs to E such that for all M follows P in E, NM follows N in D. A condition satisfied. So we want to show that X is a cluster point of S. And then the X contain an open set to stage in the. So let U be a neighborhood of X and N belongs to D. Now, given this n belongs to D, therefore there exists a P belongs to E such that for all M follows P, Nm follows N. Also, T converges to X. അതുകൊണ്ട് എക്സിനെ കണ്ടുന്ന ഏത് നെയ്ബർഹുഡ് തന്നാലും ഒരു സ്റ്റേജിന് ശേഷം മീൻസ് ഒരു സ്റ്റേജിനെ ഫോളോ ചെയ്യുന്ന എല്ലാ ടേംസിനും corresponding net terms will be in that neighborhood. Also, T converges to X, and it is given that U is a neighborhood of X. Therefore, there exists M belongs to E such that T of M belongs to U. There exists there exists a Q belongs to E such that for all M follows Q, Q. So since T converges to X, and U is a neighborhood of X, there exists a stage Q belongs to E such that for all M follows Q, Tm belongs to U. Now Tm means S composition N of M belongs to U for all M follows Q. Now M follows P in E and M follows Q in E. By definition of directed set, we can choose M such that M follows both P and Q. Now choose M such that M follows P and M follows Q. Since M follows P, that Nm follows N. Since M follows P, Nm, we call it as say M1, that follows N. M follows Q ആയതുകൊണ്ട് S of Nm belongs to U. Therefore, S of Nm is M1. SM1 belongs to U. That is our notation. SM1 belongs to U and M1 follows N. മതിയല്ലോ, ക്ലസ്റ്റർ പോയിന്റ് ആണെന്ന് പറയാൻ ഇത് മതിയല്ലോ. U എന്ന് പറയുന്ന നെയ്ബർഹുഡ് തന്നു, ഒരു സ്റ്റേജ് N belongs to D തന്നു. We showed that there is an M1 follows N such that SM1 belongs to U. Therefore, X is a cluster point of S. So, if it has a subnet converging to X, then X is a cluster point of S. If S has a subnet converging to X, then X is a cluster point of S. Conversely, we assume that X is a cluster point of S. To prove that S has a subnet converging to X. So we will construct a directed set E. We will define a function T. Then we will show that it satisfies those conditions. Okay. We know that S is a net. Therefore, S is a function from D to X, where D is a directed set. Now, it is given that X is a cluster point of S. അതുകൊണ്ട് എക്സിന്റെ ഏത് നെയ്ബർഹുഡ് എടുത്താലും എസിലെ ടേംസ് ഇടയ്ക്കിടയ്ക്ക് ആ നെയ്ബർഹുഡിൽ ഉണ്ടായിരിക്കും. ഏത് സ്റ്റേജ് തന്നാലും ആ സ്റ്റേജിന് ശേഷം ആ സ്റ്റേജിനെ ഫോളോ ചെയ്യുന്ന കുറച്ച് എലമെന്റ്സിന് S of that belongs to the neighborhood containing X. So you consider eta X, the neighborhood system at X. We define the set E is equal to D cross eta x. One second. Sorry. We define. See, eta x le ഏത് മെമ്പറിനെ തന്നാലും eta x le ഏത് മെമ്പറിനെ തന്നാലും സേ u തന്നാലും ഏതെങ്കിലുമൊക്കെ SN-കൾ യുവിൽ കാണും. എല്ലാ n-കൾക്കും SN യുവിൽ ഉണ്ടെന്ന് പറയാൻ പറ്റില്ല. Because x is a cluster point of S. ഏതോ ചില n-കൾക്ക് SN യുവിൽ ഉണ്ടാവും. അത്തരം n-കൾ എടുക്കുക. And you form an ordered pair NU, which is an element of D cross eta x, such that SN belongs to U. And you call this collection as E. Let E be the collection NU, which belongs to D cross eta x, such that SN belongs to U. And in E, define a follows, in which NU follows MV. If and only if N and M are elements of D, if and only if N follows M in D and U subset of V. Clearly, we can show that this follows satisfies all the conditions for making E as a directed set. So clearly, this relation directs E, and E is a directed set. Now define T from E to X by E le members alla ordered pair NU galana. So defined by T of NU is equal to S of N. And define N from E to D by N of NU is equal to this N. Then clearly T of NU is equal to Sn. This is S of N of NU. That is S composition N of NU. Therefore, T is identically equal to S composition N. And it is easy to check the other condition for given any n belongs to a D. Okay, for the other condition, suppose n belongs to D, given any n belongs to D, we can find P is equal to, there exists a P belongs to E in the lever end. P is equal to NX. That belongs to E. Because X is a neighborhood of X and Sn belongs to X for all n. Nx is a member of E. Then for all M is equal to Tu, which follows P is equal to Nx. Nm, by definition, N of M is N of Tu. That is T. And by our directed relation, this relation, NU follows M, N should follow M. So using that, N of M is equal to T, and T follows N. Nm follows Ni. Therefore, T satisfies all the conditions for the definition of a subnet. Therefore, T is a subnet. Therefore, T is a subnet of S. And it remains to show that T converges to X. And X contains the neighborhood. So let G be a neighborhood of X. X contains the neighborhood X S in the cluster point X is a cluster point of S. Adundu ഏതോ ചില എന്നുകൾക്ക് SN G ഉണ്ടാവും. So you fix such an N, fix an N such that Sn belongs to G. Therefore, this Ng belongs to E. Now, for all Mu follows this Ng, T of Mu is equal to S of M. That belongs to U, because S of M belongs to U. And U is a subset of G. Therefore, T of Mu belongs to G for all Mu. For example, for you take it as M1 follows N1 equal to Ng. That to show that T converges to X, we showed that there exists an N1 belongs to E, such that for all M1 follows N1, as T of M1 belongs to G. Therefore, T converges to X. And hence the theorem. അപ്പോൾ ഇത്രയും കൊണ്ട് നമ്മുടെ ടോപ്പോളജി ഈ മോഡ്യൂൾ അവസാനിച്ചു. ഞാൻ ഹോമോട്ടോപ്പിയുടെ 2 വീഡിയോ തന്നായിരുന്നല്ലോ. So we'll start our 3rd semester class from Monday onwards. അപ്പോൾ മൺഡേ വരുമ്പോൾ മെട്രിക് സ്പേസസ് ആണ് നമ്മൾ തുടങ്ങുന്നത്. So you study basic definitions of metric spaces, basic properties of metric spaces. Okay, thank you.